All right, so I'm going to talk about transversal and longitudinal waves, but first you kind of have to understand like what a wave really is. I think most of us have a good idea of like what a wave is just from our past experience with like the ocean or like just like seeing the shape of a wave. But really like what a wave is the formal definition is a disturbance through a medium from equilibrium. So what that means is like if you think about a rope, right? If you have a rope that's just initially really straight, and let's say I'm gonna give it a quick little like this end, I'm gonna quickly move up really quickly. I'm just gonna like kind of jolt it up. Then what's gonna happen is there's gonna be like a wave that forms. So you get eventually something like this, and that wave is gonna move across that medium, which is the rope. So what I did is I created a disturbance. That sounds really like dramatic, but I created a disturbance of like against like the equilibrium, right? Like I moved this up. If this is like the equilibrium where it's not like accelerating or moving at all initially, then I, gave that quick little jolt and that created that disturbance through the string, and it's gonna propagate through the string. So, and if I do that a bunch, right, I eventually, if I create a bunch of little disturbances, I get like that sinusoidal pattern that's going to be moving like so. So here are the two types of waves. The first type, I think the type that people are more like, when they hear wave, I think this is what comes to our mind, is a transversal wave. So a transverse wave, not transversal, but a transverse wave is a wave in which the motion of the particles is perpendicular to the direction of the wave. So here's the deal, right? When I have that string, right? When I had that string and I initially moved it up, I had to move it up perpendicular to the way that I wanted the wave to move. Wave's gonna move this way eventually, but I moved it up like so. It's perpendicular. So what's gonna happen is as I bring this down, let's say I bring this down slightly, then it's gonna be kind of hard to draw. Let's do it like this. Eventually what's gonna happen is as I bring this particle down, now this piece of the string is going to move this part of the string up, right? Like so. And then eventually, this part of the string is going to move this piece up. So it's going to be more like this. And then eventually, this piece is going to move this piece up, right? And then this piece everything is starting to move down as well. And then this piece is going to move this piece of the string up. And the whole idea that I'm getting at is that each of these particles are only moving up or down. This particle right here is staying here. It didn't move anywhere. Same with this one. This part is staying like by the end. It's just moving up and down. That's a transversal wave. If you think about a sports, like a sports event, when they like move their hands up and they create that really cool wave like pattern, or like that wave across the crowd, they're just moving their hands up and the wave looks like it's moving to, or I guess the wave is like that disturbance is moving whatever way, depending on who goes first, right? If they raise their hand first, and the wave is gonna follow that. I don't know. You have to visualize it, but you get the idea, hopefully. The other type of wave is a longitudinal wave. So longitudinal wave, forgot how to spell it. This wave is when the particles are moving and oscillating parallel to the direction of the motion. So an example that you might have seen in class was a slinky thing. So the slinky started off kind of pulled back, like so. Or I guess, how do I draw this? pretend like each thing, like if you're looking at from, how do I draw this? This is kind of hard to draw. So we kind of pulled it back, and then eventually what would happen is it would compress, and that spring, that spring compression would kind of move across the class like so. So kind of like that. You hope you can see this compressed part of the spring. It was moving across the class, right? What's happening to this particle as I pull it back? Well, initially, once I pull it back, right, there's that tension force being exerted on this part of the spring. So that spring is going to move forward. It's going to accelerate forward. And then it's going to kind of like, it's kind of like if you're in a line and someone pushes you, like if you like get pushed, or if you get pulled like to the person in front of you, you guys are all like together and compact, and you guys are like, you know, bumping into each other, and then that person bumps because of that, and it moves forward. It's kind of like a chain, right? This moves forward, which like compresses it, like kind of squeezes into the spring, and then that's going to move forward, and there's like these compressions that are happening, and that compression disturbance is moving across the class. But what's happening at this part is once this gets compressed, it just moves back to its original location. They're oscillating back and forth. They're not moving anywhere. Sound is really just a longitudinal wave. When I'm speaking, my vocal cords, I think, I'm not an expert on like how words come out and stuff, but I'm vibrating the air, and that air is not like moving anywhere. It's just oscillating back and forth, and those oscillations, just like how this compression is causing compression elsewhere, that vibration is causing the air next to it to vibrate, and that air causes the following air to vibrate, and it's this like chain of vibrations, just like the compression moving across the class, but the individual particles aren't going anywhere. Big idea for longitudinal is that the particles are moving parallel, like in the same direction as the wave is traveling. You also get a combo wave of like a transversal and longitudinal. That's what an ocean wave is. So like an ocean wave, the water moves up and to the side. So you get like kind of the circular kind of movement going on there. It's pretty cool. Those are the two types of waves. Hopefully this was made sense to some extent. And yeah, thank you for watching.